for inside server farms path selection for two ISP provider. As you see here, we have ISP1 and ISP2. ISP1 has subnet 202.100.0.0/16. ISP2 has 61.200.0.0/16 network. We're trying to get a server and internet access, but we want to use ISP1 as a priority over ISP2 if the servers are accessing these ISP network. If the servers are trying to access ISP2 servers, we want to use this path on the right as a priority, vice versa. So for them to access the internet, inside we create a virtual server. One IRU is for the SNAT. In this case, it's just the regular net path, PAT. And the IRU is for the path selection. Either it's using ISP1 or it's using ISP2. And then the rest will be a default in round robin. And to keep monitor the ISP links, we have chosen an important server. In ISP1, we use an server IP 202.155.10. ISP2 is IP server is 61.266.10. In the real network, there will be ISP server, ISP DNS server, and ISP2 DNS server. So if the server goes down in ISP1, and we'll put the link down because the ISP gateway IP is actually a node. In a pool, we call ISP1 gateway pool, and the important server is actually node health monitor. In this case, the ISP link is down. Everything else will go to the ISP2. For SNAT, it will be translated to a floating IP .15, and ISP1 is also .15. So that's what we're trying to do. In the lab simulation is 40-gate firewall with two loopback interfaces. Step is to create a monitors. We'll create a monitor for the important server in ISP1. Important server for ICMP. The address 202.155.10. Finish. Create another monitor for ISP2. .1 266.10. Now we created two important server as monitors. we'll go ahead creating nodes. The first node is ISP1 gateway IP. And we'll choose our host monitor ISP1 important server. Click finish. And now it's ISP2 gateway IP. 61.220.10. And we use ISP2 important server as a selected monitor. Now they're all active. We can test by disable one of the important server IP. In this lab, it would just be the rootback interface. We are disabling the rootback 1, which is the important server as ISP1. Give it a few minutes, we'll see it goes to inactive with our important server monitor. Okay, let's put it back. Now the gateway is active now. And next step is to create 3 pools. The pool 1 will be ISP1 gateway pool. We use gateway ICMP for monitor round robin. We will say that's on 1. We'll go down and choose ISP1 gateway. And in this case, because we use ISP1 gateway pool, we will select all service, gateway priority as a 10, and choose ISP2 gateway, give as priority to 5. So now this pool will always choose ISP1 gateway as long as it's active, because it has priority 10, which is over the priority 2 gateway as a 5. Okay, so click finished. That's our first pool, and similarly we'll create another pool for ISP2 gateway. So ISP2 gateway pool also use a gateway ICMP. That's the 1 priority group activation. We choose ISP2 gateway IP for all service, give it 10. And ISP1, we use 5. All right. The third pool is we call default. Also, we use default gateway ICMP. In this case, we'll post all the gateway priority actually it will be disabled for priority group activation as default 0 for all gateway. Okay. Now we have 3 pools. ISP1 gateway pool. ISP1 gateway is over ISP2 gateway as priority. ISP2 gateway pool. ISP2 gateway is over ISP1 gateway as priority. Pool the default pool actually is just a round robin. All priority is set to equal. Okay. The next we'll create a data group to identify the networks in for each ISP1 and ISP2. So ISP1 network address is set to 202.100.0.0/16. Another data group ISP2 address is 61.200.0.0/16. Click finish. At this time, we have two data group ISP1 and ISP2 for their own subnets. Where we could create our first IRU for a path selection. Actually, name it as Outbound path select. Paste my IRU. If the IP matches ISP1 for destination, we'll use our ISP1 gateway pool. If the destination IP matches ISP2 data group, we'll go use ISP gateway pool. For anything else, we use the full pool. Click finish. Let's check. We have ILU, outbound path select. This time we have taken care of the path selection. We haven't touched the SNAT yet. So let's do the SNAT. We will go to the SNAT pool list, create first pool for SNAT, SP1, called outbound path will translate to 202.110.15. Click finish. Create another one. ISP2 path outbound pool. $61,220.15. Click finish. Now we have two pools for each ISP where they are the servers are gonna be translated. Next, we'll check if I have the IP for destination. SNAT, yeah, we have two out of 10.15, 20.15 SNAT destination translation. Here I have to remind you the timeout for TCP UDP is actually indefinite. We want to change it to 20 seconds for each. Okay. Here you go. Now we'll use ILU for our SNAT translation. Go ahead, create SNAT policy, paste. If is load band selected path, and if we're going to ISP1 gateway, which is this IP, or do some logging for local logging, and select our SNAT pool we just created. Remember we translate to .15 address. This pool is called SP1, outbound path pool. For any path, we select the nodes. For ISP2 gateway IP, we use ISP2 outbound path pool. Anything else, we just do our automap for SNAT. Okay, click finish. So at this time, we have taken care of the path select and NAT, SNAT, or we call path ILUs. We are going to create now a virtual server for inside server farm. We actually call it outbound NAT virtual server. There will be a performance level 4. Source is 172 of server farm IPs, and destination we don't know to go everywhere, so it's any. It'll be of all ports. And for protocol, I actually use all protocol. Okay. For VLAN, we'll enable only on the server side interface. We do without any SAT, source address translation. Okay, let's check we have in advanced address translation uncheck. Yeah, scroll down in IRUs. Find the 2 IRU we just created. Outbound path select SNAT. Okay, so that's click finished. If you want to do some ICMP testing, ping test, we have to go this, navigate system, config local traffic. In general, on the SNAT packet forwarding, go ahead, select all traffic. Update. We can head down to testing. What I'm gonna do, I make a few ping tests to our important servers in each ISP. First, ISP1 important server can be ping. That's ping important server in ISP2. Obviously, it can be ping. Now we go to our F5. First, show the nodes of 0 translation records. Let's pin again. Okay. Let's show a record. First, ping to server 1 in SP1, translated to .15 of non-float IP, and it used the gateway for ISP1. Similarly, second ping to the ISP2 important server, it goes to .15, also the gateway of ISP2. Now we're showing 2 translation records correctly. If I can go ping our non-ISP2 ISP1 server, which is 72, 78, AA, 141. You will just use random gateway. Either it will be ISP1 or ISP2. Now it chooses ISP2. Okay. We can actually use our SSH to test which exactly is the source IP. Now source IP actually is translated from 10.15, the non-float IP we choose for ISP1. Okay, that's also remember we have put a few the logs in our IRU for SNAT translation for ISP1. Let's take a look. You can find it in our logging. So actually we have the logs for destination reaching to the important server, source IP, and gateway is the gateway of ISP1. Actually everything is getting logged. The next test is to see if the priority over round robin is going to work. We'll test ISP1, shut down the rootback interface 1, and we give a ping to ISP1 important server. Obviously, it's not going to be able to ping, but we can still see our translation record. We may need to clear it and make sure again. Actually, it's fell over to the ISP2. See, it's using the ISP2 floating IP. 15, 61.200.20.15, because the node is just showing inactive. Okay, thank you for watching.